Here's another tabular problem. It is talking about hot water dripping through a coffee maker. Okay, they tell you this function is differentiable, so again you can assume it's continuous. Part A, use the data in the table to approximate C prime of 3.5. These are selected values for C. So how do you come up with the best approximation for 3.5? I want the slope, which is C prime, and I want to use the 2 points that are closest. And it says show your work. So 12.8 minus 11.2 over 4 minus 3. I get 1.6. Use correct units. That's it. Part B. Okay. Is there a time where the derivative is equal to 2? So they want to know, is there an exact moment in time where the instantaneous rate of change is exactly 2? They give you an interval. They're talking about the derivative. That's your clue. This is your mean value theorem. Okay? So this is your interval. So what you should be trying to figure out is first, what is C of 4 minus C of 2 over 4 minus 2? And just use the values from the table. And C of 4 is 12.8. C of 2 is 8.8 over 2, and this is exactly 2. So remember, this is the slope of the secant line. So does this have to equal this value at some moment? Yes, it has to equal 2 because mean value theorem says if a function is continuous and differentiable, the average rate of change will always equal to the instantaneous rate of change as long as it meets those two conditions. So I would say yes by the mean value theorem because C of t is continuous and differentiable. Okay, part C. Use a midpoint sum again to approximate this integral. Okay, so I'm trying to figure out what this is. Okay, this 1/6 in the front is just a constant multiple, which is going to give us the average. I am going to use the midpoint sum just to come up with an approximation for that integral. So this is going to be approximately, I'm going to leave that 1/6 out there, and let's use the midpoint sum for the rest of it. So again, using this, there's my first rectangle from 0 to 2. There's my width, and the number in the middle is 5.3. There's my height. Look at the next rectangle. Again, width is 2. The middle number, height, is 11.2. And do the same thing for the last one, 2, 13.8. Okay, this is your setup. So I get 10.1 ounces here. And then they want you to explain what this means. So this is the amount of coffee. So if you just did the integral, that would be the total amount in the coffee in the cup. But what does that 1/6 do? That gives you your average. So you need to make sure that your explanation has that word average. So this is the average amount of coffee in the cup. Again, use units in ounces. And then what does these bounds mean? From t equals 0 to t equals 6 minutes. Make sure you are explaining that it goes from 0 to 6 minutes. It is not at exactly 6 minutes. It is an interval that it's happening on. Okay. Lastly, part D, find the rate at which the amount of coffee is changing. The rate is your derivative. They give you an equation for B. Use your calculator to figure out what B prime of 5 is. I actually got an exact answer, but you can figure what this out is in a decimal. It should be ounces per minute. So you can use the calculator. You can do it by hand. It's not that bad. And that's it.